Hello. I want to talk about a certain medical school topic known as pharmacokinetics. Some of us in Clovis were exposed to volume of distribution, half-life, clearance, infusion rate, loading dose, maintenance dose, all these various concepts on our first week back as second year students. And it was interesting and it was a bit much. And condensing all that information was tricky, even though all the examples were great. For me, it was tricky because it felt like a lot of the information was repetitive, but every equation looked different to me. So I tried my best to condense the entire chapter down to 4 equations, and I feel like I've got it. I've got it down to five, 4.5, 5 equations. And I'm going to talk about three of them, which should basically get you, if you get a pharmacokinetic question, whether in medical school or on boards, it should get you very far. So let's take a look. The three concepts that I decided to tackle first were loading dose, maintenance dose, and infusion rate. These are all using the exact same formula. I just could not see it. So I'm going to talk about how they're all using the exact same formula. So let's start with loading dose, which has probably the longest version of formula elaborated. So loading dose starts with this, how much you have in your plasma, what's the desired steady stream or whatever the SS stands for. And F for bioavailability. Did you take it by mouth? Okay, that's only going to be 25% effective. Did you take it by IV? Okay, that's going to be 100% effective, right? So if you're loading somebody up, you want to know how much is going to be in their blood. You want to know how how great it's going to be getting in there. Like, are we going to lose 25% of it? Okay, that was by mouth. Are we going to keep 100% of it? Okay, that was by IV. So that's got to be a factor in there. And then it's going into their body. Their body has the potential of storing it. That literally is what volume of distribution. Volume of distribution is pretty much the concept that how much can the body store. Some drugs are stored purely in the blood. Some drugs are stored in blood and other fluids outside the blood. Some drugs are stored in the blood, extra fluids, and even inside cells, right? So it's the potential. How much drug can I stuff into this person, theoretically speaking, but you pretend that you're only putting it in their blood, nowhere else. Although it's going in other places, volume of distribution asks how much drug can I stuff into a single person while pretending it's in their blood and ignoring the fact that it went other places too. So that's volume of distribution. So first of all, the reason I bring it up is this is the formula for loading dose, right? And this is the formula for loading dose right there. And it requires you to know, how much is in their blood, how is it getting there, and what's the potential of their body to hold it, right? So those things sound reasonable to memorize. Now I want to show how it's all really the same. So with maintenance dose, if you really look at it, with maintenance dose, you have the same variables. I'm going to move this down a bit. I'm going to move this down so we can see it nicely. You still have this idea of, how much plasma concentration there is, right? CSS plasma concentration, steady state plasma concentration. That means, if I don't go crazy up, I don't go crazy down, this is kind of the norm. This is the Zen. This is where it stays in the plasma, in the blood. That's steady state, right? And it still has this concept of bioavailability. Hey, how did I get it there? Did I take it via rectal? Did I take it by intramuscular, intravenous? Did I take it by mouth? So how efficient was it? 25%, 50%, 70%, 100%, whatever. So that's F, right? So nothing has changed much between loading dose and maintenance dose. What changes now is, like, it's not about potential of the body. I'm not trying to pile in all the possible drug I can into you. I'm not loading you up anymore. I'm trying to maintain you, right? In that sense, what am I really fighting against? Why am I trying to maintain it in the first place? Because your body is getting rid of it, because your body is clearing it. That's the whole reason I have to maintain it, because I have to do extra work. So that's clearance, right? So somewhere in this formula, it's not about the potential of the body anymore. Now it's about the clearance, right? Okay, so that's a factor. How quickly my body is clearing it will help me decide how much I need to maintain. Another thing I need to decide is, how many times am I giving it, right? I'm giving it once every 8 hours. I'm giving once every 9 hours. I'm giving it once every 24 hours, right? So that's the time interval that I'm giving the dose, and that's what that symbol is about, right? So it makes sense. maintenance dose is actually the same as loading dose, only when we were giving it for the very first time, we were talking about the potential of stuffing as much as we can in there, right? Loading them up fully. And when we're maintaining it, we're saying, oh, how much am I losing? How much am I excreting? And how much am I putting back in? How often am I putting it back in? So hopefully that makes some level of intuitive sense away from the rest of the equations. And you can see various forms of these equations, but they're really only two equations. Now, infusion rate, which is called K naught, really gave me trouble, but it was actually even simpler. What happens is in infusion rate, you know you're giving IV. You know you're giving IV. So there's no F. There's just the value of 1, which you can also write as 100%. 100% equals 1. So what they do is they replace F by 1. So it disappears. You often don't see it. And also your kidney is still clearing it, or your liver, I don't know, something is clearing it. So that's still a problem. That's why you're infusing them, because they're losing it. How are they losing it? By clearing it via kidneys or liver, or I don't know, sweat, crying, God knows. Now, how often are we giving it? Well, infusion, right? It's stuck in you, and it's a drip. It's constant. It's on all the time. So again, this becomes number one. This becomes 1, and bioavailability is 1. So actually, it's the same freaking equation the whole time. So what you see written, which feels new and different and extra to memorize, what you've seen written in books is this, right? You see this. Crud. There we go. This is what you see, and that seems like, oh, another equation to memorize, right? But it really isn't. These are all the same equation, and it's actually getting simplified as you move down. I mean, if you consider this simplification, but you can understand the motivation behind maintenance dose is how much am I losing and how often am I putting in. And the motivation behind loading dose is how much I can possibly get in there, how much can I shove into this person, right? So hopefully that seems simple. Now, let me just tell you why it seems confusing. If they write loading dose, they sometimes write it as CSS divided by F times VD, right? They move things around, but with maintenance dose, they tend to write clearance over here, then I think CSS over here over F, and then the interval over there, right? Like it's all freaking over the place. So this can be confusing. But if you look at it the way I organized it, it's actually really simple. It's the same exact thing, and then you're changing one thing every time. And here actually you're simplifying it further. I really hope that helps some.